Hi, I'm Darshan Kumar, Customer Success Scientist at Aiforia Technologies. In this video, I'll be shortly introducing the Aiforia Create platform, which allows you to make your own algorithms for your image analysis needs without the need for knowing coding. In this session, we'll be focusing on the workflow towards algorithm creation for some neuro-related applications with some related examples. Aiforia is a software as a service company which uses AI to predict features of interest for your image analysis needs. For using Aiforia, all you need is your PC or your computer, web browser, and your images. There's no special or heavy-duty hardware requirements or software installations are needed. With that, welcome to this session. Let's start first by the login screen. Once you have your own subscription, you'll be able to generate your own password and then log in using your user ID. Once you have logged in, your page will look something like this, where you can then start or begin by first adding your images. How to add your images? You can access the panel on the top right, and once you click on the image section, you will be able to access this long list of files which you can directly upload. We have quite many vendors that we support with their proprietary file formats, so that you do not need to change your images to TIFF or JPEG, for example. Once your images are uploaded, then they will start to appear on your subscription. Currently, I have this one image over here for which we'll be doing the demo. Once you have your image uploaded, you can open your image on our Aiforia hub, where you can also do very simple things like looking at different dimensions, the area, length, in addition to taking 4K by 4K images of a certain area within your image. Once you're happy by looking at your ground truths and understanding what your ground truths would be, the next thing would be for you to make your algorithm. We'll go directly to making an algorithm using the Aiforia Create. To access the Aiforia Create, all you need to do is to go to the logo over here, which is also the logo of the Aiforia company. Every algorithm within the Aiforia system is made via making an AI project. So one AI project will give you or yield you an algorithm that will do multiple recognitions depending on how you have structured your layers and classes, which I will talk about soon. For making an AI project, all you need to do is you need to go to the add new panel and click on AI project, go to your images, and then select the images that you would need for your training. You can put some name over here so that you are able to clearly relate to the multiple projects at some point that you would have in your subscription. I already have a pre-made AI project over here, so we can just directly use that. Once you click on your AI project, then it will show you the number of images that currently you have for the training set. I just have one over here, and that's what it displays. Once you are into your AI project, the next thing that you would need to do is to create something called as a layer tree structure. In this project, at least, or in this demo, the idea would be that we will make an algorithm that would predict microglias, and then it will also predict different processes per microglia. As you can see, we have one microglia cell over here. So the idea would be that we will make an AI that would detect only the microglia cells, not the background cells. And also at the same time, we will try and segment out or count the number of processes per cell. How you go about it first is to create the layer tree structure. The layer tree structure can be created using the edit layers button. And here you can add more layers that you would like to build up your layer tree structure. Currently, the layer tree structure looks like this. Excuse me. Where you have the resting microglia, the non-resting microglia, and underneath the resting microglia, I also have an additional layer with one class called as a processes. I'll only be annotating for the resting microglia for this demo. So the resting microglia currently is an object detector. First, we'll be detecting them as a cell, and then I'll also introduce you to instance segmentation. So first and the foremost thing to then go about once you have made your layer tree will be to make training regions. So you can make training regions using this button over here under the regions. And these training regions basically mean that this will be the region in the whole image where the algorithm is going to perform its calculation and do all the learning. It will not be learning anything from outside these training regions. Once you've made a training region, the next thing that you need to do is to annotate. So at this point, then you can annotate this cell as a microglia cell. With this annotation, we are saying to the algorithm that anything that you see within this training region is a microglia cell until and unless annotated. I can increase the training region over here a bit so that I can show some background cells, like for this one over here, or I can also include this one where we have a background cell which is not a microglia. Once we have annotated a microglia cell like this, then we can also go into the processes and then annotate the processes as well. Currently, I see one process here, and then one process here. And then I would also put in the training regions for the process layer as well. Now with this, what we will be achieving is we'll be able to count all the microglia cells within your sample set. But if you also, in addition to this, would like to have the data on how big is every microglia cell, what the borders of these look like, what is the area, what is the perimeter, what's the bounding box, then for that we have this additional feature which is very handy, and it's called as the instance segmentation. So the instance segmentation activation can happen at the edit layers section. You just click on the edit layers button, click on the edit settings, and then for your every layer you'll be able to select the use instance segmentation. So you just select that option on. You can also select different complexities depending on how complex or less complex or more complex your features would be. Then you can then save those changes. You can do the same thing for the processes as well, which I will show you later on. Okay, so when you have your X amount of annotations for X amount of microglia, then you can just go to the arrow, click on one microglia, and then you will see this instance panel that will appear below. For making the instance, you just use the pencil tool and then just make the border for the cell. It's best to make the borders as precisely as possible so that the recognition of the cell and the border happens robustly with high precision and sensitivity. At this point, it's also good to know that if you do have a mouse, it does help. But if you also have a touchpad system, then that would also be possible to use with the Aiforia platform or Aiforia Create. Okay, once you have made your instances, you can also refine them a bit. I'll just probably take out some background over here, add some additional instance over here, so on and so forth. With this, if we have enough number of annotations for the object detector with the respective instances, next thing, when we are doing the training, the algorithm will be able to detect not only where a microglia cell is, but then also it will be able to draw these borders for you. Let's do the same thing for the processes. So we'll go to the process layer, select one process. Say, for example, let's select this process over here, and then we can draw the respective instance for them. Something like that. And then let's also draw an instance for this other process. Now here we do see that this instance for this other process has some overlapping features. So you can see that there is a common feature that would belong to both the processes, which would be this region over here. If that's the case, it's easy for the instances to understand that there is a common overlap between the two. So the only thing that you would need to do is then select that object as well, and then you can also overlap those two common regions between the two processes. With that, it does not replace each other, but it is able to understand the common overlap between two features. With this, now we are done with the annotations, and of course, we need to also do the annotation for the last object of the process. It's not always necessary to draw all the instances for all the objects, but you can draw at least 10 to 15% of the total number of objects that you have. So it reduces your annotation time as well. Once we have all our annotations done for the resting microglia and for the processes for them respectively, then all we need to do is to then go ahead with making our algorithm for this purpose. We go to this gear section over here, which is the final step. We need to just name our algorithm something. Let's call it micro. You can call it whatever you like. The layers to train means that these are the two layers that we have selected, and these are the two layers that we are going to train. They directly relate to these two layers that we have created here in the layer tree structure. We put the number of iterations that would depend on the kind of complexity you have, the number of annotations you have. So the more annotations you have and the more complexity you have in your overall data, then you would need more iterations over here. You can also run the analysis, meaning that you can put some analysis regions. So next to the training region, you have the analysis region, where you can then put either the whole image to analysis, or you can just put one small region to analysis, something like that. This is a good way for you to also get the data of this region out once your analysis is complete, and once your algorithm has been made. The final step, of course, at this point is to go ahead with making or creating your algorithm. You can also click on the run analysis so that your analysis regions are also ready by the time your algorithm has been made and verified. So we'll click on create AI model, and the next step after the algorithm has completed itself, you will find the results on the right hand side over here. I already have some pre-made algorithms just so that we can easily go through it right now. So once we have the total number of annotations in, it will show you an error percentage that you would need to refine, and then also the analysis results that you have currently generated. This algorithm is, of course, would need more annotations for your errors to come down, but this is just to show you the different kind of errors that it will give you, and then it needs to refine further on. Once your algorithm is created and generated, all you need to do is to release your AI model. I have this one AI model which I have generated, and assuming that I'm very happy with that AI model, I'll just click that AI model and then go on the right hand side panel by clicking the edit AI model first. Once I click the edit AI model on the right hand side panel, I'll get some more options where I can select dimensions and circumferences. So once I have my object being detected, I'll also get bounding boxes and additional measurements that you can also extract per data analysis. We can also have spatial metrics. So if you want to see what is the distance between one object and the other object, then you can also add these spatial metrics over here by selecting what object you need and to what object you want the distance to, and what would be your maximum search distance. And you can save that metrics as well. Once you're happy with all the additional features that you have added, then the last thing that you would need to do is to release your AI model. For releasing your AI model, you just click on the release AI model, and then here on the left hand side you can see that a green light appears next to your algorithm over here, and then it also reads with the text released. But the release over here means that now the algorithm is ready, and now it is available for you to do your bulk image analysis needs for at Aiforia Hub. Meaning that we'll just go outside the AI project at this point of time, click on our find our image, click on our image, click on the analyze option on top, and then either we can do the analysis for the whole image. We just need to select what image that we want to do the analysis on. Let's just pick, say, one of them, and then you can do the analysis for the whole image. If you don't want to do the analysis for the whole image, you can also choose smaller regions of interest, like for example this one that I've made over here. Select that one and then do the start analysis. Once the analysis is complete, you'll be able to view the results. I already have some pre-done analysis where you can clearly understand and view the results. So this is an algorithm that was basically made for the recognition of microglia and respectively the processes. So how the recognition workflow basically goes is that the Aiforia engines are first going to detect all the microglia cells in your image or your analysis window, and then also detect the instances if you have the instance segmentation on and if you have annotations for those instances. The same goes for the processes as well. So that's how you would go from point A to point B when it goes from your images to your image analysis and recognition and data output. You can easily export your data here. You can get either an Excel file or you can also get the CSV file that you can further work on and compile your data. At this point, I would also like to show you some examples on other different kind of brain applications or neuro-related applications that we have worked with. Here we have a brain slice with a recognition of a molecular layer and the Purkinje layer with their respective interneuron, Purkinje cells, etc. On the left-hand side panel, we have this panel where you can easily switch on and switch off different layers so that you can easily go through your data. Here we also have distance measurements that I was talking about, so meaning that you can easily calculate distances of one object to the other object or one kind of layer to the other kind of layer to understand how far they are and if they exist in that specific range that you have provided in the morphometric analysis. Another example here are of neurons from the immunofluorescence or multi-channel staining. Here you are able to see apoptotic cells because they have a certain additional fluorescent channel which the DAPI and MAP2 do not have. This is another example for calculating things like gray matter, white matter, the glia in the gray matter, so on and so forth. At different zoom levels, you are able to access a heat map. So the heat map kind of also tells you the density of your result in a specific area. So when you have high number of cell counts in a specific area, then you can easily zoom over there and then get your data out to understand what is the density over there. Then we have some alpha-synuclein and neurite data over here. So you can easily train the algorithm or you can easily train the neural network to understand what is a neurite, what is not a neurite. Then you can also get the data on how long they are or what is the area, what is the perimeter, what's the intensity. Often researchers would need what kind of intensity values per neurite you have. So if that's of interest to you, then that kind of data also you can easily extract by the Aiforia software platform. Another example over here I would like to point out Th positive neurons. This is also quite an easy, actually quite easy algorithm for us to make, or for you as a user to make, where even if the cells are quite dense, very close to each other, you can easily teach the algorithm to understand what is a cell, what is a positive neuron, what is a negative neuron, and what kind of different metrics you would need to calculate those out as well. Another very similar kind of data analysis for the TH neurons, where the staining is different, but of course, once you have your right training data set and the training that has been performed, then it's very easy for you to make an algorithm that would be able to easily count all these cells that you can see in front of you, instead of any manual counting that was probably done in the past. And finally, another example. So this is an example of astrocytes. So that's a lot of data over here. So the heat map is quite full, as you can see. But just to give you an idea over here, when you are looking at different kind of cells, you can segment them out quite easily using the Aiforia software. So these are just the astrocytes. And in this case, although the astrocytes are not touching each other, but even if they are touching each other, they can easily be separated out using the instance mode. And that's a very useful tool in this case, so that one astrocyte does not merge with another astrocyte, and then you can still get all your data out in the correct way possible. Well, with that, I hope you enjoyed this session. I hope you got to know some new features about the Aiforia software, especially about the instance segmentation and how you can leverage it for your neuro-related applications. Please visit our website for more information, and thank you so much for listening.